This course provides a general understanding of the hazards, precautions, and potential consequences associated with combustible dust in the workplace. It will help you recognize combustible dust hazards at your location and provide good housekeeping practices that will help minimize the likelihood of an explosion in the workplace. This course does not provide technical information suitable to engineers who design, build, and maintain equipment and facilities. March 3rd started out as an ordinary day for the employees of Wood Pharmaceuticals. Little did they know that by the day's end, their lives would be changed forever. You see, on that day, an explosion and fire at the Wood Pharmaceuticals plant in Fernside, Alabama, killed 8 workers and injured at least 47 others, including 3 responding firefighters. When it was over, what had earlier that day been a successful plastic packaging facility now lay in ruins. Many families lost their jobs that day. Worse still, some even lost family and friends. For those affected by the fire, the events of March 3rd will live forever in their hearts and minds. Found that industrial employers experienced 280 combustible dust fires that resulted in over 100 fatalities and 700 injuries. That is a tremendous loss, especially since these types of events are largely preventable. My name's Taylor. I know firsthand just how tremendous this loss can be. You see, I was there. I was the lead investigator on the Wood Pharmaceuticals case. But today, I'll be your moderator, and I'll share my experience with you throughout this course. One thing's for sure. Combustible dust fires can be catastrophic, resulting in serious injury, property damage, and even the loss of life. But luckily, these events can be prevented by understanding the hazards and potential consequences associated with combustible dust, and by implementing and following adequate safety measures that include good housekeeping practices, thorough routine inspections, proper reporting, and appropriate personal protective equipment, or PPE. After completing this course, you will be able to define combustible dust, detect combustible dust hazards in the workplace, describe safety measures you can use to prevent combustible dust fires and explosions, and identify the proper PPE to wear to protect yourself in the event of a combustible dust fire or explosion. So, what exactly do we mean by combustible dust? As the term suggests, combustible dust is dust that can ignite and burn. It's produced when manufacturing powders, such as cornstarch or aluminum powder coatings, or by handling and processing solid combustible materials, such as wood, coal, and plastic. Polishing, grinding, transporting, and shaping many of these materials can produce very small airborne dust particles. Combustible dust can also come from materials not normally considered combustible. For example, metal fines in an aluminum manufacturing plant, flours or sugars in a food processing plant, and powders in a pharmaceutical lab. Under certain conditions and in high enough concentrations, these dust particles can ignite or even explode when subjected to a heat source. Any material that burns in a solid form can be explosive when in a finely divided form. Finer particles burn more easily because they react a lot faster with oxygen when floating in the air and coming in contact with an ignition source. This is what happens in a suspended dust fire. These fires are extremely volatile. However, sometimes it's hard to know if a certain dust is combustible or not. Luckily, you have some useful sources in that case. While a safety data sheet may be a good place to start, you should also refer to OSHA's list of combustible dusts in case the SDS doesn't contain what you need. But if you have any doubt, a sample should be sent to a lab for formal testing to give you a definite answer. Take a look at OSHA's list of possible combustible dusts by clicking the link shown. You may even be surprised by some of what you see on this list. You should know, though, that this is not a definitive source. If you have any question about a specific material, check with your supervisor or safety manager. Remember, the type of material and size of the dust affect how easily it catches fire and how dangerous that fire can actually be. The National Fire Protection Association officially defines combustible dust as a combustible particulate solid that presents a fire or flash fire hazard when suspended in air or some other oxidizing medium over a range of concentrations regardless of particle size or shape. So what does that definition mean to you? Basically, when dust is scattered into the air and a flame or heat source is nearby, that dust can ignite and catch fire. Now that you have learned what combustible dust is, it's time to check your understanding of who can be affected by combustible dust fires. Are the following statements true or false? Combustible dust fires only happen in plants that manufacture wood products. Processes used to produce steel pipes, plastic pellets, and flour may produce combustible dust. Combustible dust fires aren't just limited to dust burning in the air. Dust can also catch fire when allowed to build up on a flat surface that is near an ignition source. Dust fires can even trigger a series of dangerous explosions. Let's look at why surface fires happen. Surface fires occur when dust accumulates near an ignition source. For example, imagine a thick layer of dust on the floor. During operations, slag from a welding torch or electrical arcing from a motor produces sparks that land on the dust. That dust can quickly catch fire, burn, and spread, creating a very dangerous situation. A surface fire can spread quickly, or it can simply smolder in place. Because the dust can get into hard-to-reach areas, such as on top of overhead beams or behind large pieces of equipment, smoldering fires can be a challenge to detect and put out. A smoldering pile of dust may not be noticed until it's too late and it has turned into a serious fire. The main thing you need to remember is that all dust fires are dangerous, whether it is a surface fire or our next type of fire. Let's talk about suspended dust fires. When enough combustible dust is floating in the air and near an ignition source, a suspended dust fire can happen. Most suspended dust fires are deflagrations or flash fires, which are intense and sudden fires that can happen without any warning. The more dust that is floating in the air near an ignition source, the greater the risk of a flash fire happening. This last type of combustible dust fire can be the most devastating. Fires that develop suddenly, like a suspended dust fire, cause a violent pressure wave. When a fire is in a confined area or trapped inside a wall, the pressure can build rapidly and will eventually explode. The intense heat and extreme force of an explosion can hurl equipment, seriously burn you, or worse yet, kill you. So, remember what I said earlier? All dust fires are dangerous. While dust fires can happen anywhere there is combustible dust and an ignition source, certain work areas have to be treated more carefully. Work areas that have the potential to contain hazardous or ignitable concentrations of dust may be considered classified. These classified areas must have signs posted that tell you what hazards are present and what you must do to protect yourself. Because these areas can have dangerous amounts of dust, you must be careful not to introduce an ignition source into the area. As covered in OSHA's Hazardous Location Class 2 standards, special equipment and materials used in these areas need to be dust-tight or dust ignition-proof to prevent the dust from catching fire. When working in a classified location, be sure to use non-sparking tools and electronic devices. This includes using approved electrical equipment and wiring resistant to static and sparking, operating specially rated and approved powered industrial forklifts and equipment, wearing flame-resistant clothing that can protect you and minimize your burns in the event of a flash fire, and prohibiting all known ignition sources, such as not allowing welding and other hot work in the classified area because of the sparks and open flame associated with the work. These precautions are in place for a reason, and no, that reason is not to make your job more difficult. These special precautions actually reduce the risk of a dust fire and are meant to protect you. If you work in a classified area, you should always check with your supervisor before bringing in new materials, installing a new piece of equipment, or changing a work procedure. Believe me, you could be creating a dangerous situation without even realizing it. What many people don't realize is that a fire can trigger a dangerous chain reaction of events. Combustible dust fires can include both primary and secondary fires. Let me explain the difference. A primary event is the initial fire. For example, when a pile of dust on the floor catches fire, that fire is considered the primary event. If that fire suddenly intensifies or emergency responders disrupt other dust near the fire, that dust can also catch fire. That second fire was caused by the primary event. Secondary events can affect work areas throughout an entire facility. Most often, secondary events begin with accumulating dust that, over time, settles on flat surfaces in a work area. When a primary event happens, the settled dust can be lofted into the air, creating a suspended dust cloud. The initial fire then ignites the dust cloud and results in a serious fire event. With all that said, the most important point I can stress is that seemingly insignificant fires can trigger powerful secondary events. You must take all dust fires seriously. Dan works for a furniture company in the sanding shop. While using a large belt sander, he fails to notice sawdust settling around the motor. Continuous operation during the day causes the motor to overheat and ignites the sawdust. The accumulated sawdust quickly catches fire. Dan rushes to use the fire extinguisher. While trying to put out the fire, he bumps into a large shelving unit next to the sander, lofting accumulated dust from the top shelf into the air. The dust cloud ignites, resulting in a flash fire suspended in air. Which three actions could Dan have done differently to prevent the secondary events? A. Clean the sander and immediate work area periodically throughout the day. B. Allowed the primary fire to burn out to prevent disturbing other dust in the area. C. Utilized a collection system to remove dust at the source. Or D. Routinely cleaned the entire work area, including all shelving, fixtures, and equipment. Now that you recognize dust can accumulate in lots of places, click the numbers in order, beginning with the number 1, to learn why each of these areas is a potential dust fire hazard. So just how much is too much? It is nearly impossible to have a completely dust-free facility. However, to prevent a combustible dust hazard, you must clean, and clean often, to prevent dust from accumulating to a dangerous thickness. If the dust in your area is more than 1/32 of an inch and covers more than 5% of a surface area, including the floor or overhead areas, you must clean immediately. To give you a visual, 1/32 of an inch thick is equal to the diameter of a paperclip wire, or the thickness of a piece of lead in a mechanical pencil. When you are cleaning to remove dust, you cannot clean in a way that creates dust clouds. You may cause an ordinarily safe, non-hazardous area to become one that now has dangerous levels of airborne dust. For example, using compressed air to clean a large work area can cause a bigger combustible dust hazard than not cleaning. Why? Because dust clouds are a fire and explosion hazard, and certain dusts are unhealthy to breathe. In addition to avoiding dangerous clouds, you must not blow dust into electrical equipment that could cause it to catch fire. I'm not saying to never use compressed air to clean. However, the National Fire Protection Association recommends against using compressed air or steam unless you first vacuum accumulated dust from all surfaces. Make sure the air pressure doesn't exceed 15 pounds per square inch. And eliminate all ignition sources before cleaning. Let's take a few moments to explore some of these suggested methods for cleaning. Mopping and washing. Before using wet methods of cleaning, make sure you survey the area for any electrical equipment that needs to be de-energized or avoided during washdown. Also, check for drains and find out if there are environmental concerns related to the washdown. Determine if the dust in the area is reactive with water. For example, powdered metal dusts mixed with water may react and give off dangerous gases, or touching a wet material could cause an adverse skin reaction. When using wet cleaning methods, always wear slip-resistant footwear and be careful. Vacuuming. Use vacuum systems specifically rated for the type of dust you are collecting. This helps to prevent static electricity or other ignition sources produced by the vacuum. You may also need a vacuum with a special filter that does not exhaust dust back into the air. Exhausted dust can be a fire and explosion hazard, as well as dangerous to your health. Before using a vacuum for dust removal, be sure to read and follow the manufacturer's instructions, because the equipment may require special bonding and grounding to prevent a static charge. When other methods cannot be used, sweeping can be a safe way to clean your area. Just make sure that you don't create a dust cloud and circulate the dust back into the air or onto other surfaces. In your work area and throughout the entire facility, it's important to have structured housekeeping and inspection plans, because dust tends to settle in areas where you may not think to look. Are you safe? R is for establishing routine schedules for cleaning and inspecting your work area. U is to remind you to look in the usual areas requiring special attention, such as hidden and overhead spots. S is to make sure you follow safe cleaning and inspection procedures. A is for communicating the actions needed to resolve any high-risk hazard. F is for following up to make sure the hazard has been resolved. E is to remind you that you must keep your work area clean and safe every day. You must be able to recognize any potential problems in your work area and facility, as well as report any hazards you may find. Remember to stay safe. Now that you have learned how to inspect a work area for potential dust hazards, it's time to make your recommendations for removing these hazards. Match the best prevention method to each hazard. I want you to think back to the opening headlines based on true events when we began this course. Do you remember that the tragic events of that March afternoon changed the lives of many? What went wrong? I can tell you, because I was one of the investigators there that day. I'm going to share with you what we discovered at the plant. After you read our findings, you will have an opportunity to help make recommendations that could have prevented or at least minimized the damages caused by that tragic event. The Wood facility manufactured polymer plastic packaging for prescription drugs. We determined that a thick layer of accumulated dust hidden above a suspended ceiling fueled the primary explosion. However, due to the extensive damage at the facility, we were never able to determine the actual event that caused the dust to catch fire in the first place. During our investigation, we did identify multiple mistakes that led to the tragic explosion. Number 1. Work areas were not routinely inspected and had significant dust accumulation. Number 2. The facilities were in disrepair, and dust had accumulated in hidden areas that were never cleaned. Number 3. Employees didn't know the dangers of introducing ignition sources into classified work areas. Number 4. Employees never took action to remove dust hazards in their work areas, and they never escalated problems they couldn't manage on their own. Number 5. Employees were not wearing flame-resistant clothing, which could have reduced the severity of their injuries. To prevent a combustible dust fire similar to wood pharmaceuticals, match the recommended prevention method to mistakes identified during the investigation. The investigators determined that the following factors contributed to the incident. Combustible dust fires are preventable and don't have to be catastrophic events. By capturing dust at the source, limiting accumulation through good housekeeping, and controlling ignition sources, you can prevent fires and avoid deadly situations. Now that you have completed this course, you have learned that combustible dust is any dust that burns and can be produced from both combustible materials and materials people seldom think of as combustible, such as metal. Dust that accumulates in open and hidden areas or is dispersed into the air can lead to catastrophic fires and explosions. Good housekeeping methods and formal inspection processes reduce the potential of a combustible dust incident. And wearing proper PPE, such as flame-resistant clothing, can minimize injuries if a combustible dust event happens. Using this information, you should be able to apply what you learned to your work area. While this course provides you with an awareness of the hazards and precautions associated with combustible dust, Review your facility's operating, maintenance, and emergency plans, and check with your supervisor or safety manager for additional information. State and local authorities, the fire marshal's office, your company, and your company's insurance carrier may require precautions that are more stringent.